Hello, welcome back from the discussion on the final exam solutions of DSCA course. This is part 3. We are going to discuss part B questions here, starting from question 11. Now let us look at the question here. For the circuit given below, give the output F. Okay, you are supposed to give the output F, either it is with respect to X or is there going to be a fixed value, either 0 or 1. Because this is a Boolean circuit, of course it will have either 0 or 1, but it could be based on the input also. So it could be X or X prime also. So these are the four possible combinations or possible values that F can have based on the input as well as the circuit and the components which are used. Here what are the gates being used? XOR gate is used, X NOT. Actually it is a NOT is there in front of the XOR gate. So how will you find out what is the output F? What is the value of output F? Is it with respect to X or is it a 0 or 1? So you need to give the steps or at least give a value of 0 or 1 and then trace it so that you will be able to justify what is the value you are getting it in the exam. So now let us look into it, how to solve it. If suppose you are given a circuit like this and then asked to find out what is the value of F, how will you do it? Now the simple thing is feed in some value. Let us feed a 0 here. Now if I feed a 0 here, this is also 0 and this is also going to be 0 because this is the same signal which is getting fed to the XOR gate. This is XOR followed by a NOT, X NOT. Now if 0 0 is there, it will give a 0, but NOT will make it 1, so this will be 1. Now what is coming here? This is all directly connected. Now you may find a circuit with a NOT here, but if there is no NOT here, that means the same signal is coming. So let us say that 0 is coming here because the same signal is, we are feeding 0 here. So this also will be 0. Now what is this value? This is 1. Now 0 and 1 XOR is going to give 1 here and NOT of this is 0. Now two values are same, then there is no NOT here, it's a pure XOR gate, so F is equal to 0. That means when X is equal to 0, F is equal to 0. Okay, this is what we found. So let me write, if X is equal to 0, I am going to get F is equal to 0. Now what is that? Is that, can I conclude now that this is the value? No. You have to make sure that you cannot say that F is equal to X now, because unless you find what is the value that I am going to get, if X is equal to 1, I cannot say that F will be equal to X. I can't even say F is equal to 0 also, because it could be that F is same as X. So let us verify that now. Okay. Now let me change the color to retain the old values. Now just track 1 is being given here. If I give 1 here, this is also going to be 1. This is also going to be 1. If two inputs are same, this is going to be 1. Then output will be 0 here. Now this same 1 is coming here, so this is going to be 1 here. Now 0 and 1 is going to result in a 1 here. Output will be 0 here. But this 1 is coming here, right? This is, all the blue signals you see. Now what is the value? It is going to be 1 here. Now did I do anything wrong here? So let us just verify it. Okay, I said that two inputs are 1. I think you might have noticed it now. I gave two inputs 1 and then said this is going to be 1, which is wrong, right? If I am giving two same input, this is going to be 0. So sorry about the mistake. So it has to be, just XOR is going to give me a 0, NOT of that is going to be 1. So this is going to be 1. Okay, so rest of it is 1 is coming here, 1 1. So this is going to be 0 just before the NOR gate. That this NOT of that will be 1. Okay, so this is also 1, this is also 1. So this result is going to be 0. So please be careful here. You are likely to make mistake. And if suppose it is better to draw another diagram and check, or maybe erase the values so that you don't make a mistake here. You give two ones here, then the XOR is going to give a 0, then NOT of that is going to be 1. So this is correct. And the same input 1 is coming here, so this is correct. Now same input again for the XOR here, so this is going to be 0, NOT of that will be 1. This remains as 1 because there is no complement or anything, the same signal is coming here. So this is going to be 1. So 1, 1 is going to give us 0. That means if I give x is equal to 1, f is going to be 0 again. That means this is not correct. F is equal to x, you cannot say. F remains 0 irrespective of whatever is the value of x. 0 or 1 is going to be 0. So you need to say the final answer is f is equal to 0 is the expression. What is the output? It is not s same as x, or it's not same as 1. It's not equal to 1. It is equal to 0. Okay. I hope this is clear to you. The correct answer is f is equal to 0. Now, let us look at the next question. This 2 marks question. So, you need to be a little bit careful in finding the values. Now, give the truth table for the circuit below. All the gates given below are AND gates. It's all AND gates. Okay. So, what is the truth table given this circuit? So, you have to painfully go through this again and then find out what is the truth table. Now, what are the possible values? You will get A, B, and output is Y. Now you will have 0, 0, 0, 1, 1, 0, 1, 1. Now you have to find out the value of Y when I am giving each input. So let us say 0, 0. This is going to be 0, 0. Everything is 0, right? That's all. So this is going to be 0. Now let me change the color for every input so that you get to know 0, 1. Now this is 0, 1. Now let me write it up behind this so that now you have the values. This is going to be 0. Now you are giving a 0 here. This is going to be 0. Okay. And 1 is coming here. But 0 is here anyway. So this is going to be 0 and it is 0. So fine. Now let me change again the color. A is 1. B is 0. Now doesn't matter. This is 0, 1, but 1 and 0, this is also 0. Here you get a 1 here, but the other input is 0 here. Okay. Yeah, other input is 0 here. So this is going to be 0. So this is 0. Fine. So this is going to be 0. Now finally, unless you verify everything, you can't be sure what is going to be the value. So let me pick a color which is red. 1, 1. Now if this is 1, this is going to be 1. Anyway, 1 is coming here, so this is going to be 1. And because 1 is coming here, 1, this is 1, and then 2 inputs are 1, so this is going to be 1. So this is a 1. That means, does it look like a normal AND gate? Even though you have so many AND gates, finally this can be simplified as one AND gate. Okay. Now you could also do it with the Boolean expression. You can construct and then simplify it, but given the time limit, I leave it to you which one you want to do. But this is a sure method of finding out correctly the value. So but you have to make sure that you don't make any mistakes in the middle. So this is going to be a simple AND gate. Fine. Now let us look at the other question. Draw the output waveform Y. Okay, this is Y of the 4 to 1 line multiplexer. So 4 to 1 line multiplexer. You should know what is a 4 to 1 line multiplexer first, and then solving this problem. Okay, let us just look at it now. Now, what is, I think if you are not able to see, a 0 not, and this is S1 not. So what is S? S is a select input. It's a control input. Okay, control signal. Now if you look at this circuit, S is S0 and S1 are given to both all the AND gates. Now if you see the order in which they are fed, okay, let me write it as S0, S1. Okay, now what are the possible combinations values that you can give? Both zeros, then 0, 1, 1, 0, 1, 1. Now what does it mean? Let us see. Now what is being fed to this AND gate? Okay, this is the first AND gate. You see that S1 prime is used, S0 prime is used. That means if I give a 0 here, okay, it will be a 1 here. Okay, 1 1. That means this value is not. If I give this combination, I am going to make this 2 as 1. That means whatever the third input I am giving is what is going to be output. So if I give this, output y will be d naught. Okay. Now what about the other things? How will you be sure that these other things are all zeros? Because if I want the d naught to come out, all other things should be 0. Then only d naught, if it is 0, it will be 0. If d naught is equal to 1, it will be 1. That means I need to make sure that all other output are 0. Then you look at the combination of these control inputs, whatever control inputs we are giving. We are giving S1 prime here and S0 directly here. Okay. Now 0 0 being there, okay, 0 0 is, if you give here, what happens is this will be 1, but here S0 is given as it is. Okay, 0 1 0. That means S0 is coming directly from here. That means if one of the input is 0, output is going to be 0. Similarly, if you check these two input, they will be, one of them will be 0, then output will be 0. So effectively what you are doing is, if I call it as, okay, D0, this is a D0 is selected. Okay, if this is D0, if I give a 0 1, D1 will be selected, this is D2 will be selected, and D3 will be selected, 1 1. So basically it's a 1 to 4. Okay, sorry, 2 to 4. Now I am giving a selection of this encoder. Okay, actually this multiplexer, actually what we are doing is, we are either one of the output will be output. So what is a multiplexer? It will either get an output directly from D0 or D1 or D2 or D3. How do you choose it? You choose it by this control signal. If it is 0 0, I will choose D0 to come out, but some other time I will give 0 1, then I will get D1 out. So it's actually multiplexing many of the inputs, one of the inputs from many, one of the inputs coming out of the as an output. Okay, it's a multiplexing different inputs by choosing one of them at the time, because you cannot have multiple inputs simultaneously given as an output. So you have to choose one of them. So you are multiplexing one of the inputs. It's like, suppose if where is you use the multiplexer. Suppose I have a TV channel, TV. I cannot display two images or two channels together, right? I can see only a channel 1 or channel 2. By remote control, I am choosing one of them, and then the TV is going to give me that channel, whatever is coming in that channel. So we are actually multiplexing different cable operators giving us different channels. We are multiplexing them and then seeing one at a time. Similarly, whether D0 will come out or D1 will come out based on, or D2, D3 based on the control signal which is fed. So now what is asked for you to draw the output? This is Y. Now this Y is going to be based on the control signal which is being given, and then what is that output at that time, what is the input at that time, sorry. So if suppose I am saying 0 S0 0 and S1 as 0 0, I am going to choose D0 to come out. Now whatever is the value of D0, that is going to come out, so I will write 0. Okay, low value. And then what is this here? I am saying S0 being 1, S0 being 1 and S1 being 0. That means I am going to choose D1 here at this time. So let me write it here. D0 is coming out. Here D1 is coming out. Now S1 being 1 0, that means D2 is going to come out. Okay, D2. 1 1 means it is going to be D3. 0 0 again D0. This is D1 and D2. Okay, that's all. Once you write these things, it is easy to find out at this particular instant whatever is the value of D0 or D1 or D2 or D3 will come out. Now at this moment, whatever is the value of D1 should come out. Now what is here at D1? This is 1. So this output will be 1. So it is going to follow D1 at this point in time. Then I am choosing the control signal to choose whatever is in D2 to come out. Now what is in D2? This is the D2. So let me tick here. So D2 is 1. So sorry, 0. So it is going to be 0. Now I'm going to choose D3 here. So what is the value given at D3 at this moment? It is 0. So it will continue to be 0. Actually, it is outputting the value of D3. Okay, so remember It's not outputting the value of D2. D2 happens to be low and this is also a low, but you should remember that D3 is coming out here because you have chosen 1, 1. Now again going back to D0 value. Now what is the D0 value? Here it is 1. So let me draw it like this. Now I am choosing D1 here. So D1 happens to be 0. So it will be 0. Then this is going to be 1, 0. So please remember which is S0 and S1. Accordingly write down this so that you don't mix up these two. So here S1 is 1 and S0 is 0. So D2 is again chosen. So what is the value of D2? You have to be careful here. It's low. So it continues to be low here. So once you write these values properly and then you have taken care of S0, S1 properly and understood the circuit and what is the multiplexer's job, then coming up with the output is not a difficult thing. So this is done. Q13 is done. Very good. Now let us go to 14, question 14. Now, as I told you, this particular course is a mix of digital circuits and electronics, then digital design. So you will get questions from different topics that have been covered in this course. So very simple, but I will looks complex though. Let us simplify this and then understand it better. I am supposed to find out what is the current value I2. Okay. I have shown the directions of I1 and then the value of this current and the voltage. Now, how will you look into this circuit? Okay. You have to remember KCL, KVL, which is the first module taught in this course. What is KCL? I already explained in the part A discussion. Current coming in to a node is what is the sum of all the current coming into a node is equal to sum of currents going out of the node. That is KCL. Now, what is KVL? KV is the total voltage inside a loop. If you sum up the voltages of inside a loop, that will all be equal to 0. It's a conservation of energy. Okay. So all the sum of voltages of a closed loop circuit will be 0. So these two are the basic laws with which we are going to solve this problem. Now you are supposed to find the value of I2. You don't know what is I1, but this current you know. So remember, this is shown as a current source. So it is feeding in the same current 5 ampere is coming here. And then I1 is shown outside. Doesn't mean that it is cannot be shown here. It is I1. Now what is shown here is a I2. Now you can see that KCL can be applied here, right? What are the currents coming in? I1 is coming in, 5 ampere is coming in, I2 is going out in this node X. Okay. So at node X, apply KCL. Simple. Okay. You apply the basic laws, you will be able to solve it. So you have to be very clear about the directions. So I1 and 5 ampere. So I will write I1 plus 5. Assume that I1 and I2 are amperes only. So 2 input current is equal to output current, which is I2. One equation is done. Fine. Now with this you cannot solve this problem. So you need to apply KVL also. So let me now erase some part of it so that it looks easy for you. Now KCL is done, so I am erasing it. Okay. Now let us apply KVL. Maybe I will use a different color. Now KVL, where do I apply? I can apply here because voltage is source is also given. Now this is the direction. Okay. Now remember, this is I1 and this is I2. Now what is the equation? One more thing you have to remember. There is a passive convention of voltage. Okay. When a current is entering a resistor, this will be positive and this will be negative voltage. Okay. Similarly, current is shown to be entering the resistor, so plus minus. These are all passive components will have. This is a passive notation of voltages, and voltage source will be showing current is coming out of the positive terminal, and passive terminals. Passive terminal means it dissipates the heat, and the active element is generating the current. So positive terminal will give out the current, and then in the passive element current will be entering the positive terminal. So voltage across this will be shown as a plus minus. So if I have to write a KVL, okay, KVL across this, I have to start from here. I can start from anywhere. So let me start from here. What I encounter here, minus I am encountering. So minus 6, okay. Then plus I1 into, okay, let me show you that, okay. 10 ohms, I1 into 10 ohms, I1 plus 10, okay. And then I am showing the current I2 being flowing into this being going into the R2 or whatever 20 ohms resistor. So the current is entering it positive terminal. So I am encountering a positive here. Don't go into this loop, okay. This is just feeding the current. So you have to complete this one loop which is here, okay. So I2 into 20 equal to 0. So we come back here. So this entire voltage is equal to 0. Now, can I write it in another form? I1, okay. So let me write it as normally 10 I1 plus 20 I2 equal to 6. So I found that second equation. Now, I have two equations and two unknowns. You know how to solve it, right? So let us now use my, already I have a equations written here. So let me show that to you instead of writing it again. Okay. Now I1 plus 5 equal to I2, one equation. Then I1 can be written as in terms, I1 can be written in terms of I2. And then we have 10 I1 and 20 I2 equal to 6. Then I substitute the value here, I1 value in terms of I2. Then I compute the value of, okay, now let me erase everything. Then you will have clarity on what is happening here. Two equations we found, and then we are substituting the value of I1 in terms of I2 and expand it out, and we get this value. Then compute the value of I2 here, which is nothing but 1.8678. So just follow this simple expression evaluation, and then substituting the value of I1 into this another equation and solving it. Okay, that's all. I hope this is clear to you. I'm not going to go into the details of how to solve it. I'm sure you will be able to do that. Now let us just finish off this question 15 before we break and then get into the next part 4 of the discussion. Now give the truth table of 2 to 4 binary decoder. Now, okay, now let me talk about that maybe with the, what is a decoder? So let us first, 2 to 4 binary decoder. That means, so what is 2 to, let us understand the question here. Truth table of the 2 to 4 binary decoder. Assume active low out and outputs as Q0 to Q3. Now, 2 input and you get 4 outputs. It's a decoder. Okay, you are decoding what are the two combinations given, 0 0 or 0 1 or 1 0 or 1 1. Now 4 outputs are there, Q0, Q1, Q2 and Q3. Okay, these are the inputs given to it. Okay, let me write it like this, and then one of these inputs. Now this should correspond to Q0. I should only one of this output should be 1. Okay, one of the output should be 1 or 0. Now based on the assumption, now what is that active low outputs? Now active low output means, as I told you, it should be 0 for to indicate that Q0 is being decoded. That means this is 0, the rest of it is 1. Okay, active low, remember active low. Active low will be, a truth table will be like this. Now if it is 0 1, you have to choose this. Rest of it should be 1 1. Then if it is 1 0 0, sorry, let me erase it. Let me tell you, this is not, okay, I made a mistake here. Let me erase it. This should be 1, okay, this should be 1, and this is 0, and this is 1, and then 1 1 is 1 1 0. So let me write it here for clarity purpose. 0 1 1 0 1 1. So let us remove it. Now what is happening is, this is active low circuit, and for a 0 0 input, Q0 is selected, 0 1 is Q1 is selected, 1 0 is Q2 is selected, 1 1 means Q3 is selected. We get active low, I am making it a 0, then other things are all made 1s. Okay, that's what it indicates. So if suppose if I tell you that it is active high circuit, what will happen is, the truth table for the the same input, what you will be giving is, the diagonally all will be 1, the rest of it will be 0. The other diagonal matrix elements will be all 1s, and rest of it will be 0. So that's what is the active low and active high decoder. Okay, so this is about 2 to 4, and if it is 3 to 8, it will be a huge table. Okay, that's all about the decoder circuit. Okay, so let us stop here. We will continue with the discussion in the part 4, the balance question, 5 questions that we have in part B. See you. Bye bye.